Afternoon, good morning, good evening if you're watching this at nighttime. All right, this is the entirety, this is a special day. This is an entirety of the assignment number five's notes for unit number 3. Expected value in regards to spinners. All right, so here is what expected value is if you're unsure of what it is. Expected value is the average you would expect to get per spin. Expected value is the average you would expect to get per spin. Now, so you think of expected value as the average of what you would expect to get. So what that means is that many cases, when you find expected value of a spinner in regards to a spinner, you're going to get an answer that is not going to be any of the values that are actually in the spinner. And the reason for that is because essentially we are finding the average of what you expect to get. So here's the example that we are going to go over, and we are going to find the expected value of this spinner right here. So we have a spinner, and it is divided up into 4 sections. None of these sections, or 2 of the sections, are equal. They are 45 degrees of the circle. One of the sections is 90 degrees of the circle, and then one of the sections is obviously half of the circle. If your spinner lands in the half of the circle, you get $0. If your spinner lands anywhere in the 90 degree section of the circle, you get $4. If your spinner lands in the bottom 45 degree section, you win $16, but if it lands in the top section, you win $40, okay? So this is the spinner right here, and we are going to find expected value. What's our expected value of this spinner? In other words, what would I expect to get per spin? Here's how we do it. You are going to take one section at a time. We're going to start with the section right there that I just highlighted in yellow, the section that is worth $0. And what you do is you take the probability of that section. Okay, so you're going to take the probability of your spinner landing in that section, and then you are going to multiply that probability with the value that the section is. Okay? And then you're going to repeat that process, probability of the section multiplied with the value of the section, and you're going to repeat that process for however many sections there are. And this spinner has 4 sections, so we are going to repeat that process for each one of the spinners. So this would be for the yellow section, and then we're going to have a blue section, and then you add those values up. And whatever you get at the very end, that's going to be what we call our expected value. In other words, what's the average you would expect to get per spin? Okay, so let's go through these, and as you can see, I am color coding each one of the sections, yellow, blue, green, and purple. And for each one of the sections, I'm going to figure out what's the probability of the spinner landing in that section. In the yellow section, that is 1/2. And then I'm going to multiply that with the value of the section, which is 0. That yellow section, it is 1/2 of the spinner. That means it has a 1/2 probability. I'm going to multiply that with the value. 1/2 times 0 is 0. And then I'm going to repeat that process for each one of the sections. Okay? The blue section, which has a value of $4, is 1/4 of the circle. It has the probability of the spinner landing anywhere in the blue section, which is worth $4, is 1/4. Okay? 1/4 multiplied with 4 is 1. Then I'm going to add that with the green section. The green section is worth $16, and the fraction of the circle that the green section is, it is 45 degrees, if you notice. Out of 360 degrees, which is a full circle, we reduce that down, and that tells us the probability of the spinner landing in the green section is 1/8. So 1/8 multiplied with 16 is 2. Then I'm going to add that with the purple section's value, which is $40. And then the probability that my spinner is going to land in the purple section is the same as the green section, which is 1/8. And 1/8 multiplied with 40 is 5. So I add those up and I get $8. So that right there, that $8, that is my expected value of this spinner. Okay, now if you notice, like I said earlier, that answer, there is not an $8 section anywhere in this spinner. But it's not, so what this $8 is telling us is that's on average what you would expect to get per spin. So on every spin, on average, you would expect to get $8, okay? All right, moving on to the next section. Now we're going to do a little bit of editing. I want you to take this entire title, Spinner's Central Angles, Probability and Expected Value, cross it out, and we're going to change the title to Union and Intersection, okay? We are going to change the title for this second section here to Union and Intersection. And the reason why we're going to do that is because the test for Unit 3 is slightly changed. And we need to go over union and we need to go over intersection. I'm going to give you definitions of each one. Union, the definition of union is all outcomes that are in one or the other. Give you a definition of intersection. Then I'm going to give you an example of each one. Intersection is all outcomes that are in both. Okay? All right. Here's my problem that I have. I've got two people, Bob and Nancy. Bob and Nancy are my two people. Bob likes the following toppings on his pizza: ham, bacon, olives, and sardines. Pretty nasty pizza there. A ham, bacon, olive, sardine pizza. Nancy likes onions, mushrooms, and bacon. Okay? So we would refer to the set of toppings for Bob as ham, bacon, olives, and sardines. The set of toppings for Nancy on her pizza is onions, mushrooms, bacon. Okay? We're going to find the union of Bob and Nancy's toppings, and then we're going to find the intersection between Bob and Nancy's toppings, okay? So the union is all outcomes that are in one or the other. So if I said, what is the union between Bob and Nancy's toppings? The union would be everything that Bob likes as a topping, or all outcomes in one or the other, or everything that Nancy likes as a topping. So the union would be ham, bacon, olives, sardines, onions, and mushrooms. Notice that although Nancy likes bacon, I had already written bacon for Bob, so I don't have to repeat it. So the union of the toppings of Bob, what Bob likes and what Nancy likes, would be, notice, it's everything in Bob or it's everything in Nancy, and I don't repeat anything. So I don't have to write bacon twice, okay? So that would be the union of the toppings. If I said, what is the intersection of what toppings Bob likes with what toppings Nancy likes, notice intersection is, it's all outcomes that are in both. So it's going to be the toppings that both Bob and Nancy like, and the only topping that they both like would be bacon. So the intersection of the toppings for their pizza would be bacon. Okay? So there is union versus intersection. All right? Moving on to the next thing. Expected value with spinners. So we're going to edit this a little bit. Keep the word spinner and cross out all the other words after spinner. So our title for this section is going to be spinners, comma, probability, comma, and frequency. Okay? And what we're going to have here in this problem is we're going to recreate the exact spinner that we created at the beginning of today's notes. So we're basically going to take the spinner that we had from the first part, and we're just going to recreate it again, with the exception of I'm still going to have the 4 sections, but I'm not going to have number values in each section here. What I'm going to have is I'm going to put letters instead of number values for this example. So we have 2 45-degree sections. We have a 90-degree section, and then we have the sections that's half of the circle. We're going to have an A, one section is B, then we're going to have section C and section D. And what we're going to do is we're going to make a table here. We're going to have 4 rows in our table, 1 for each section of the one that represents each section of the spinner, A, B, C, and D. And then we're going to have, our table is going to have 3 columns. First column is going to be the letters. Second column is going to be probability. And then the third column is going to be frequency. Okay, so the second column is going to be titled probability. Probability. Sorry, I have to say that out loud, or if not, I spell it wrong all the time. And the third column is going to be frequency out of 40 spins. Out of 40 spins. Okay, so first of all, let's fill out the probability column. Remember, when you're doing a spinner, the probability of each section is the fraction that the section is of the spinner. Okay, So section A is 180 degrees out of 360 degrees. That makes it 1/2 of the spinner. So because section A is 1/2 of the spinner, that means the probability of the spinner landing in A is 1/2. Section B, if you notice, is 90 degrees out of a full circle, which is 360 degrees. We reduce that down. That tells us that section B is 1/4 of the spinner. So that means the probability of my spinner landing in section B is 1/4. Okay. Section C and D are both 45 degrees out of 360 degrees. They're both the same, so I could pretty much do them at the same time. And both of those fractions reduce down to 1/8. So that means the probability that the spinner is going to land in either section C or section D is 1/8. Okay, so that's going to be how we find probability. Notice what I did to find probability of each section. I took the degrees that the section was out of 360. 360 represents a full circle, and I just reduced those fractions down. Okay, now, to find the frequency that I would expect the spinner to land in each one of those sections out of 40 spins, what I do is I take the 40, because I'm going to spin the spinner 40 times, and I multiply that with the probability of the spinner landing in that particular section. So since section A is 1/2 of the circle, that means out of the 40 spins, the probability of the spinner landing in section A is 1/2. That means half of 40 is the frequency that the spinner should land in anywhere in section A in 40 spins should be 20. So it should land in section A 20 times. And I repeat this process, taking the number of spins, 40, multiplying it by the probability of it landing in that section. For B, it would be 40 times 1/4, and whatever that equals, that's the frequency of how many times I would expect the spinner to land. So I would expect the spinner to land 10 times somewhere in section B out of the 40 spins. For C and D, they're going to be the same answer because they have the same probability. So you're going to take the 40 and you're going to multiply it with the probability, which is 1/8. And 1/8 multiplied with 40 gives me 5. So the frequency, or the number of times that I would expect the spinner to land in C or to land in D out of the 40 spins would be 5. Okay? Last section. Isosceles triangles, base angles, and vertex angles. So a couple of things about this. First of all, remember an isosceles triangle is defined as a triangle with two equal sides. Okay? So an isosceles triangle means it has two equal sides. All right? Now, the two angles that are not attached to the equal sides, all right, are called the base angles. So that angle down there and that angle down there. So basically, the two angles that are across from the two equal sides, those two angles are what are known as the base angles of this isosceles triangle. All right? And then the third angle, that is not one of the base angles. So that angle right there, that blue one, that angle is what is known as the vertex angle. Okay, so that angle right there is what is known as the vertex angle. So every isosceles triangle always has two base angles and it has one vertex angle. The base angles aren't always on the bottom. The base angles are, if you notice, let's go to the vertex angle. The vertex angle is the angle where the two equal sides touch. The other two angles are the base angles, okay? Now, this is very important because base angles are congruent. So when you have an isosceles triangle, the base angles are going to be congruent. And what you could do is you could use this to help you solve certain problems, okay, involving angles with isosceles triangles. So I'm going to give you two different situations where we're going to find missing angles of an isosceles triangle. So in the first one, we're going to make it very straightforward. We are going to find the value of x, and we are going to find the value of y. In the second equation, we are also going to find the value of two angles, but they're going to be w and z. Okay, now in the first angle, this bottom left angle, I'm telling you, is 50 degrees. I'm going to give that to you. Okay, now watch how we find the value of x and the value of y. We use the fact that in an isosceles triangle, two of the angles are called the base angles. The other angle is called the vertex angle. The vertex angle is always the angle that is where the two equal sides intersect. So as you can see in this problem, that angle right there, that is the vertex angle, where the y is. So the y is the vertex angle in this first example, and then the 50 degrees and the x angle, those are what we refer to as my base angles. Okay, so now the rule is the base angles are congruent. Okay, so if you notice, if one base angle is 50, that means the other base angle, which is x would have to be 50 degrees. Okay, now, then to find y, what we do is we use the fact that the three angles in a triangle always add up to 180 degrees. If x is 50, we're going to go 50 plus 50, that is 100. So then y is going to be 180 degrees, which is always the three angles of a triangle, minus the 100 degrees, which is what the two base angles add up to. So y would have to be 80 degrees. Okay. Moving to the other example, I'm going to tell you that this angle down here on the right is we're going to make it 70 degrees. Okay. Now, that 70-degree angle, notice that's the angle where the two equal sides intersect. Notice, that's an equal side, that's an equal side. They intersect, those two sides intersect at that 70-degree angle. So that 70-degree angle is the vertex angle of the isosceles triangle, which means that those two angles there, where the W and the Z is, those are what are known as the base angles. Okay? Now, the base angles are congruent when the triangle's isosceles. So what this tells me is that W is the same degrees as Z. They're equal to each other. Okay? So now watch how I figure out what W and Z are. I know that I've already used up 70 degrees of the triangle, and there's 180 degrees in a triangle, so that means there's 110 degrees left for both of these angles here. So W and Z have to together make 110 degrees. Okay, so that tells me that angle W, however many degrees that is, plus Z has to be 110, but W has to be equal to Z. So to find out how much W and Z are, I just divide 110 by 2. That is 55 degrees. So that tells me that W is equal to 55 and Z is also equal to 55. Unit 3, assignment number 5's notes.